Wow, this is another opportunity. My brother, my sister, was the last class. Were you able to go through it and have a nice time with what we discussed? Is there any challenge? At this start, there's no challenge. I believe God. Without there must be no challenge by now. Everything is still at the beginning or introduction of the class. But one thing you just need is that you need to have a consistency. And I want to beg of you, don't miss any series of these presentations. Likewise, whenever you click, don't forget to subscribe so that for the next series that will be uploaded, you will have the signal that this other series is available for you to follow up. And please don't forget to write your own comments so that we will try all that's within our own capacity to make chemistry simple for you. And if it is your own word, your own child that's having that issue, and you have the opportunity to stumble on this station, please don't hesitate to write your comments after each series. We will try to meet up with your own taste. And for those of you at higher level, don't worry. All of you are within the budget. We put budget of all together. We just want to ensure that those one behind, we want to match them up so that we can go together and the journey is very smooth. Now, let's continue with the class. So, we stopped at the preparation of arcane the last class. Today, let's quickly see two. Let me quickly mention one or two physical properties. Physical properties. Properties of arcane. Let me mention like two. That is, we have the first one, melting. Melting point and boiling point increases with increase in number of carbon. With increase in number of carbon. Now, that means when the number of carbon move from 1 to 2, 3, and so on and so forth, as the number of carbon increases, likewise, the melting point and the boiling point also increase. Let's look about the state of matters too. The state of matters, states of matter. On the state of matter, we have generally, the normal state of matter is more than 3 nowadays, but the one we're going to deal here, we are going to deal with 3 states of matter. The first one is known as the gaseous state. The gaseous state. The gaseous state. 2, liquid state. Liquid state. And the third one is we have the solid state. Solid state. On the aspect of the gaseous state, there are usually gases, and that will start from C1 to C4. And these ones, they are gaseous. They are from C5 to C14, or let me say C15, once they are liquid in nature. Then we have from C16 to and above. This one are in solid state. And the last one I want to mention in this one, let me name this one Mavigo 1, 2, and 3. So, then number 3, we have they are insoluble in water. All organic substances are insoluble in water. Let me give an instance: kerosene or petrol. If you pour it inside water and you mix it, will it mix? Not at all. It will never mix together. So that is that about that. Let's move on to the next level. Let's speak about the chemical properties of arcane. properties of alkane. One, we talk about the combustion reaction, and some textbooks may even call it oxidation reaction. Then the second one is called substitution reaction. So, this reaction. Let's start with the first one. When you talk about combustion, combustion reaction. Alright. On combustion reaction is just a reaction of oxygen with alkane. And I also have it at the back of your mind that most reactions with organic compounds normally give us the end product usually be carbon dioxide and water. Except for occasional cases when you have excess of that alkane or in limited supply of air. But normally you have the carbon dioxide and water as the final product. How does it go? So when you react alkane, you have CH4 plus oxygen. What you expect as the outcome is carbon dioxide plus water. So methane, this is methane, this is oxygen, and this is what carbon dioxide. And this is what we call water. So, on this aspect, please, I beg of you, whenever you have your reaction, ensure you balance the equation. Balancing of the equation prove your level of prudency or effectiveness in your chemistry. Without balancing of the equation is an half-done work. You need to ensure you balance the equation. Let's quickly balance this equation. How many carbon here? 1. How many here? 1. Let's think about hydrogen. Hydrogen is 4 here, but here is 2. How can you make this one 4? What we multiply with 2 to give you 4? What is it? 2. So what you just need to do is just put the 2 at the back of this one. But take other things in consideration. If the number of oxygen cannot be balanced with 2, then that means what you balance here will be wrong. Let's see maybe that's what you apply is true. Here we have 2 and here we have 3. Okay, here we have 2 and these 2 apply to these 2 as you're making 2 plus 2 making 4. So in order to balance this one as well, we also have 2. So number of carbon, number of oxygen and number of hydrogen, everything is balanced. And that is the first reaction on the alkane. Let's quickly consider the second one. The second one is called the substitution reaction. On the substitution reaction, all of you have really have an idea of what we call substitution in your mathematics. In your mathematics, you have on your simultaneous equation, we have substitution reaction, and we have on that mathematics you are still familiar with it. That is good. Some of you are recording that. That is nice. Now, on the substitution simply means the placing an existing element in a compound with another one. Then that we call substitution. We are still going to use methane for that reaction. So we have CH4 plus Cl2. Remember that chlorine is diatomic in nature. Usually put C here. Don't just write Cl. When you write Cl, we are just representing a symbol alone. But in a reaction or in a chemical form, it must have 2 because it's a diatomic element. So, and this one will only need sunlight for the reaction to be ignited. Sunlight is what you just need. And in the presence of sunlight, chlorine reaction occur without any reagent, without any chemical reagents in that or catalyst to speed such reaction. So now this one with what will not be the expected outcome? The expected outcome will not be CH3Cl plus Cl plus H2 plus HCl. You will look at it, it's a miracle. will split it down because the purpose is just to make chemistry simple for you. Now, this is what I've done here. This is the methane having this hydrogen plus chlorine. This are the bonds. So what's going to happen is that this chlorine will be discharged and come to this place, and hydrogen go to this place. And at the end of the day, this chlorine has been replaced. Then we have it in this way. This chlorine has been replaced become Cl, hydrogen, 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 then hydrogen fluoride. So that is the simple method of making the reaction. So we are going to continue the replacement of the previous one. Now, how do you name this compound? Very simple. How many chlorine do we have here? We have one. Then we call it mono. And this is chlorine. We call it mono. Let me write this here. This is the name of the mono, chloro, and it's one carbon that is called methane. We call monochloromethane. That is the name of the compound. And this one is called hydrochloric acid. Chloric acid. Are we together? Alright? Good job, you. Meet me for the next one. This reaction still continue. We'll be replacing the chlorine and hydrogen with chlorine, CH3, Cl plus another Cl. Then, as we did the reaction, so since you know the method, don't let me continue to not to save our time. There will be a replacement of another one chlorine with this. Out of these three, one will be replaced become CH2. How many chlorine do we now have here? How many? 2. We have Cl2 plus one chlorine has migrated to this place become HCl. Now, I don't want to be doing tautology. This hydrochloric acid will be the second product at each level. I would not like to write in the name of this one, but I'll continue writing the name of this new product form. How many chlorine do we have here now? We have 2. And what do you call 2? Di. That is good. We have dichloro methane. Good job, you. So let's move on to the next one. We have Cl2 plus Cl2. When this reacts, this chlorine is going to replace 2 out of these 2. One is going to replace again. We have CHCl3 plus HCl. Alright, so if 1 is called mono, 2 is called di, what is 3? Do you have idea? It's called what? Tri. That is good. We have trichloro. Still remember the major name of the compound? Methane. Then the last one, but not the least, we have CHCl3 plus Cl2. Then this one we call CCl4. All the hydrogen has been replaced. Then we have lastly we have HCl. In organic in a chemistry, this is what we call chain reaction. So lastly, the name of this one is what? We have 4 chlorine. It's now become what? Tetrachloromethane. So that is the final name. So this one, you don't need to cram anything about it. Just do the end product of each. Just a step-by-step thing without mixing 2 or 3 things together. I would like to, so from here, I would like to take you to the next level of the discussion. So from here, let us quickly see what we call nomenclature. Nomenclature simply means on how to name the compound. Some students have this issue of how we don't know how to name it. No, don't worry, just calm down. It is a very easy thing. You access it with ease. Now, how to name it? You need to consider the following rules. The nomenclature rules, you need to consider it. One of the rules is this. 1. consider the longest chain. Longest chain. Don't worry, I will explain them one after the other when I come to isomers. I will break it down from that aspect. 2, you need to consider the branch chain. Branch or alkyl attachment. Alkyl attachments. What are those things that are added to that longer chain? Is it a carbon? Is it a functional group? Is it O? Is it oxygen? Is it chlorine? Is it bromine? So you need to consider all those 1. Now 3, when you have complex compound, complex structure, you name it alphabetically. Name alphabetically. Now, for instance, you may have chlorine, you may also have bromine. Then, in that situation, when you are having such kind of combination, you need to name alphabetically. So, then another one I want you to consider when you are also doing that is that on the longer chain, your numbering must start from the closest attachment. So, when you have this one, at this point, you need to consider, because sometimes we have different attachments. It can be methane, it can be ethane. So you need to consider, is it at the extreme end? Maybe one is having extreme of 2 carbon before the attachment, and the other one is having 3. Don't worry, when you get to the isomers, I'll give you the download about that. By special grace of God, in the next series, I'm going to deal majorly on those naming of those compound on the isomer. My brother, my friend, what is that problem? Just submit it. Don't worry. It's going to be a solution. There's a great solution with you here. And God will help us with that. But one of the major things is that ensure you go through it at all times. It's an interesting subject, very simple to learn. But don't forget to subscribe whenever you come online. Thank you. Meet you in the next class.